So welcome everyone. My name is Randorff Højen. I'm a member of SNOMED International's implementation support team. I want to thank you all for attending this implementation webinar. So the title of today's session is Unlocking the Power of Post-Coordination, New Implementation Guidance and Real-World Use Cases. For the next 90 minutes, you'll hear a number of different presentations, all focusing on post-coordination principles, use cases, and implementation advice. As shown on this slide, we have the pleasure of welcoming 4 external presenters from the SNOMED CT community. So together with my colleague Kewley, I'm pleased to welcome Dr. Hyeoun-Ae Park from Hyeoun-Ae, South Korea, Elze Groot from NICTIS, National Release Center of the Netherlands, Jørn and Jørgensen from Vestfold and Telemark County in Norway, and Lawley from the Australian eHealth Research Centre, CSIRO. I want to thank you all for accepting the invitation to speak here today. So here you see an outline for the session. We'll start with an introduction to post-coordination and the new practical guide. Then we'll hear 3 presentations on the real-life use cases and implementation approaches for post-coordination. Then we'll hear a couple of presentations on how to enable post-coordination in the terminology server. And at the end, there will be time for questions. So please use the Q&A or in the Zoom Q&A function to submit your question. So we really hope that you will enjoy the session. But now I'll start with an introduction to post-coordination. So the idea of post-coordination has been well known since the establishment of SNOMED CT and even before that. And although SNOMED CT is designed to allow new meanings to be composed, there has been a lack in guidance on how to do this and a lack of implementations demonstrating the safe and effective use of post-coordination. But given the fact that more implementers of SNOMED CT are exploring the options to apply post-coordination to meet their requirements, we felt the need to develop more guidance in this area. So as a result, we have now published the new practical guide to post-coordination. And this guide has been under development for the last couple of years, where the SNOMED CT Computable Languages project group has been actively trying to clarify use cases, principles, and implementation advice for anyone attempting to apply post-coordination with SNOMED CT. So if you haven't already looked at this guide, I recommend that you take a look via the URL you see here. And we encourage you to follow the implementation approaches outlined in the guide on a trial basis to evaluate their effectiveness and suitability for your specific use case. And please reach out to us if you have any questions or experiences that you would like to share. But let me start by introducing concepts and expressions. So a SNOMED CT concept represents a clinical idea with a unique identifier that is distributed as part of a SNOMED CT release. Concepts are linked to terms by descriptions, which provide a human-readable representation of the meaning of a concept. Additionally, they are related to each other by relationships, where each relationship represents a defining property of the concept that is the source of the relationship. These defining relationships provide a machine-processable representation of the concept's meaning, and the relationships form the basis of SNOMED CT's knowledge graph. And whether it's pre-coordinated concepts or post-coordinated expressions, these needs to be properly placed in this knowledge graph to be safely applied in clinical practice. A SNOMED CT expression is comparable to a concept in the sense that it also represents a single clinical idea or single clinical meaning. However, an expression is a structured combination of one or more concept identifiers. SNOMED International distinguishes between 2 main types of expressions: pre-coordinated expressions and post-coordinated expressions. Pre-coordinated expressions contain a single concept identifier and optionally one of the terms associated with the concept to make the expression human-readable. For example, a pre-coordinated expression, which means fracture of tibia, can be represented as the SNOMED CT identifier for this concept optionally followed by the term fracture of tibia, placed in vertical bars. The second type of expression is called a postcoordinated expression. And postcoordinated expressions normally contain two or more concept identifiers. And you see an example here on the slide for fracture of tibia, which can be read as fracture of lower leg with a finding site equal to bone structure of tibia. When you work with postcoordination, it's very important to understand the role of the SNOMED CT concept model. The concept model is a set of rules that governs the way in which concepts and expressions are permitted to be modeled using relationships to other concepts. These rules are critical to the consistent modeling of SNOMED CT content, which in turn determines the extent to which reproducible logical inferences can be made. And these logical inferences are the foundation for the effective use of SNOMED CT when it comes to retrieval and reuse of clinical information that is captured with SNOMED CT. For each attribute or each SNOMED CT relationship defined in SNOMED, the concept model specifies the set of rules to support the proper application of these relationships, including the attribute domain. And the domain is the set of concepts to which the attribute may apply. The attribute range, which is the set of concepts that may be used as the target for that relationship. The attribute cardinality, which is the minimum and maximum number of times that attribute may appear in a concept definition. The attribute grouping, which is whether an attribute may or may not belong in a relationship group. And the attribute in-group cardinality, which then determines the minimum and maximum number of times that an attribute may appear within a relationship group. And it's really important to understand these rules so that when you're creating an expression, you do so in a way that conforms to the concept model. And the reason why this is so important is that in order to be able to query postcoordinated expressions, you need to be able to classify them using a description logic reasoner. As you know, SNOMED CT is built on a foundation of description logic. So classification is a process that automatically compares each expression with each of the concepts in the SNOMED CT edition that you rely on to determine where the expression sits in the hierarchy, what it's a subtype of, and what inferences that can be made. And it's this process that makes expressions queryable. I'll explain a bit more on that later in the presentation. So by using the SNOMED CT concept model, we can ensure that the formal meaning of an expression is captured in a consistent and machine processable way. And this is also where the MRCM comes in, the machine readable concept model. The machine readable concept model represents the rules from SNOMED CT's concept model in a way that is computer processable. And the MRCM is published and versioned with each international release of SNOMED CT as a set of reference sets. And you can find the specification for these reference sets at the URL you see here on the slide. If you want to explore the full set of rules in the concept model, you can also go to the MRCM browser, and you can access that from the front page of the SNOMED CT browser or via the URL you see here. So when SNOMED CT authors create concepts for the international edition of SNOMED CT, they rely on the concept model rules, but they also heavily rely on a set of documented editorial principles or editorial guidelines. And these guidelines are used to support the consistent modeling of specific types of clinical concepts, such as specific diseases, specific procedures that require a specific and agreed modeling. So therefore, the creation of expressions should be performed by people with the required knowledge of these editorial principles or assisted by tools that facilitate the proper creation of expressions. The syntax that is used to represent SNOMED CT expressions is called the compositional grammar. And this is a formal grammar describing the symbols that you use when, and you can use on how the different parts of an expression can be constructed. And you can refer to the compositional grammar specification and guide, the link you see here, for the full details on the compositional grammar. However, a compositional grammar expression begins with an optional definition status, and it contains one or more focus concepts, where these focus concepts come from the same top-level hierarchy. And optionally, expressions may also have a refinement. And each of these each refinement may contain grouped or ungrouped attribute value pairs. So an attribute value pair consists of the attribute or relationship, and the name of the attribute, together with the value of the attribute. So the attribute value is either an expression or a concrete value. In its most concise form, a compositional grammar expression can be represented in what we call the canonical form. And this form excludes white spaces, it excludes terms, and it orders the attributes and groups according to a documented rationale. So the canonical form of an expression supports the computer processability and comparison of the expression. So this is purely for computers, as you can see. There's no human readability here. Now I just want to touch on the general use cases for post-coordination before we dive into some real examples in the next set of presentations. So post-coordination can be used to capture new clinical meanings in a health record that can't be represented using pre-coordinated concepts. They can also be used to share clinical information or clinical data between systems, for example, in an HL7 message or FHIR resource. It can enable interoperability between different structural representations of the same meaning. Expressions can also be used to map from another code system to SNOMED CT, for example, from interface terms to an equivalent representation of the meaning using a SNOMED CT expression. Post-coordination can also be used by natural language processing tools to represent the coded meaning of the free text, where there is a specific context or a greater amount of detail in the free text than you can capture with a single pre-coordinated code. So for most of these cases, it's normally sufficient to use pre-coordinated concepts. So not all of these use cases require post-coordination, but they can, but it can also be a mixture of the two. But before you launch into a solution with post-coordination for these use cases, I think it's very important to understand that in some cases, there are alternatives to post-coordination that may be easier to implement. And there are two main alternatives. And firstly, and perhaps the most obvious one, is to add new clinical meanings to an extension as pre-coordinated content, because this allows you to use standard SNOMED CT authoring tools to classify the concepts and distribute them in a way that support queries. However, this alternative is just not an option for everyone, and this also does not also require the ongoing maintenance of the content and the formal release process. The second alternative is to define the post-coordination structure using the information model, using separate coded data elements for the focus concept and each of the refinements values in the expression. For example, rather than using an expression for a fracture of foot, as you see it here, you could have two separate data elements, one to record the SNOMED CT concept for fracture and the other one to record the SNOMED CT concept for foot. But with that said, when is it that you want to start using post-coordination? And there are some criteria that needs to be satisfied. So if you need to represent new clinical meanings without being dependent on specific pre-coordinated content to exist in SNOMED, or you can't change the information structures to align with the published content, then post-coordination may be an option to consider. However, you can only use post-coordination if the clinical meaning that you need falls within the scope of SNOMED CT and within the scope of the concept model. So it's important to keep in mind that not all clinical meanings can be fully represented using the SNOMED CT concept model or the editorial guidance. Thirdly, you should not attempt to use post-coordination unless you have a good understanding of the tooling that is required to implement post-coordination safely. And of course, you also need to have access to that type of tooling. You'll see some examples of the tools later. So with these cautions in mind, let's assume that we've decided that it is appropriate to use post-coordination in the electronic health record solution. So to do this, we have a terminology repository containing a published SNOMED CT edition, and then you also have an expression repository to hold the post-coordinated expressions. And to simplify the implementation of these, we're going to make these available to the electronic health record via an API or an application programming interface. And that can make key electronic health record tasks such as entry, display, query, and exchange of expressions possible in the same way as for pre-coordinated content. The role of the expression repository here is to store the post-coordinated expressions and the different forms that are required. And the responsibility of the server is also to then establish the services required to work with these expressions. But once an expression is created and validated against the syntax, the expression should be stored in the same form as it was entered by the user. We call this form the close-to-user form. The close-to-user form is the faithful representation of the clinical meaning as it was entered by the user. So this is the primary stored and communicated view of the clinical information, reflecting what the clinician actually entered or the person who created the expression. But after the expressions are classified, we also need to store the necessary normal form. So the necessary normal form of an expression is the inferred view, and it includes all the relationships that are necessarily true for this expression with redundancy removed. The necessary normal form represents the necessary relationships, and these are used for querying. So this becomes part of your substrate when you run an ECL or expression constraint over your substrate. So this necessary normal form is comparable to the form that we use when we query over the published SNOMED CT content. But to get from the close-to-user form to the NNF or the necessary normal form, there may be an intermediate step required to ensure that the expression conforms to all the concept model rules and is classifiable. We call this intermediate expression for the classifiable form expression. And depending on the approach you have taken to the creation of the expression and the capabilities of your terminology server, transformation of the expression will allow any non-MRCM compliant expressions to be classifiable or transformed into a classifiable form, which can then be used as an input to the classifier. So in summary, either expressions are created in a classifiable form, in which case the close-to-user form will be the same as the classifiable form and can be used as input to the classifier. Or if the close-to-user form is not MRCM compliant, you will need a transformation to prepare the expression for classification. And the types of transformation supported depends on the individual implementations. So let's take a look at why we need this classifiable form of an expression. On this slide, you see 3 different clinical systems, which each record that the patient has a malignant melanoma of the left shoulder. However, due to different clinical workflows and information model designs, each system collects this information slightly differently. The first system records a diagnosis of malignant melanoma with a side of left shoulder. The second one records the diagnosis malignant melanoma with a side of shoulder and a laterality of left. And the last one documents the malignant melanoma of shoulder with a side of left. So the close-to-user form expression for each of these systems matches the way the data was collected on the user interface. And this means that each of these expressions are different. So in this case, it's fairly easy to work out that these 3 expressions represent the same clinical idea or meaning. But how can the system answer questions about these expressions if they are each represented in a different way? And I can tell you that none of these expressions are classifiable in the way that they are currently written. So in this slide, I just want to show you how each of these expressions can be represented in their classifiable form. So for all 3 cases, the proper grouping is missing, so there's no groups stated. And in the last case here, you can see that laterality of left actually applies to the procedure or body structure domain. And here we are in the disorder domain. So we also need to to apply a nested expression to make this classifiable, to make sure that the laterality applies to the body side of this concept. So we had 3 different close to user forms, and that transformed into what you see here, 2 different classifiable forms. And when these classifiable forms are input to a classifier, the description logic reasoner will produce a necessary normal form. And for all of these expressions, the necessary normal form will be the same. And generating this necessary normal form is important when implementing post-coordinated expressions, because it's a prerequisite for being able to query and use expressions in the same way as the pre-coordinated content. So suppose we want to query an electronic health record data store, and we have our terminology repository so that we can query the terminology, and we also have an expression repository so that we can query over the expressions. So in this example, we have different disorders related to malignant melanoma, represented either by pre-coordinated concepts up here and post-coordinated expressions down here. So suppose we have a population of patients whose clinical records are stored, and now we want to query these data. And these patients have been diagnosed with one of these conditions. Some people have been diagnosed with a condition represented by a concept, and others have been diagnosed with a condition represented by one of these expressions. So you may want to ask your EHR or your analytics application, which patients have a type of malignant melanoma of shoulder, or who has a mass of some body structure, or which patients have a malignant neoplastic disease. So these are the kinds of queries that you may want to ask. So when we ask these questions, we want to make sure that all relevant patients are returned by the query, whether or not their diagnosis was recorded using a pre-coordinated concept or a post-coordinated expression. So this slide shows a small part of the SNOMED CT hierarchy with some of the subtypes of malignant melanoma of shoulder. Some of the supertypes. And if we consider the question, find all masses of some body structure, we can quickly identify the pre-coordinated concepts that are descendant or self of mass of body structure. And we do this with an expression constraint. But how do we work out if these expressions that we have in our expression repository also match our query? And the way to do this is by classifying the expressions together with the published concepts to determine where they sit in the hierarchy and what additional inferences we can make. When we do this, we discover that these expressions are in fact a subtype of malignant melanoma of shoulder, and therefore they should also be returned in the result of this query together with the relevant concepts. So as you can hear from this short introduction, post-coordination with SNOMED is not just about composing meanings. No, it requires a lot more to implement. You need a system, electronic health record system, that supports the creation, storage, query, and exchange, maybe using expression identifiers and human readable terms. We haven't spoken about that, but that's all documented in the guide as well. You also need a terminology server with the services that support the proper creation, potentially also transformations, but at least the classification of your expressions. And also the seamless ability to query over both pre-coordinated and post-coordinated content together using the expression constraint language. So I'll leave this here, but all of the content that I've presented here are documented in more detail in the guide. And now I would like to hand over to our presenters. And the first presenter I would like to welcome is Dr. Hyeoun-Ae Park from Health ONT in South Korea. So Dr. Park is a true pioneer of health informatics in South Korea. She introduced many nationwide health informatics initiatives, such as the Health Center Information Systems and Emergency Information Network System in Korea. And currently she's involved in developing national health IT initiatives, such as the National Health Data Interoperability Roadmap, especially focusing on health standard terminologies, such as SNOMED, LOINC, and ICD. So welcome, Hyeoun-Ae Park.
Thank you. Can I share my screen?
Yes, please do.
Okay. Oh. So can you see my screen?
Yes, we see it.
Okay. Hi, I'm Hyeoun-Ae from Seoul, Korea. I'll be presenting Korean use cases and approaches to SNOMED CT post-coordination. And after I heard Anna, I am afraid that maybe we only identified areas where we need post-coordinated expression rather than implementing it yet. But I'll go
That's
ahead.
absolutely fine.
Okay, so let me begin my presentation by introducing a brief SNOMED CT history in Korea. Korea joined SNOMED International in August 2020 as a 39th member. And Korean Health Information Services serves as a national release center at the moment. Currently, we are working very hard to develop Korean extension by adding Korean descriptions and adding new concepts with English and Korean descriptions. We will be hosting 2024 business meeting and expo next year. So I hope I'll see you all there next year. Okay, Korean Ministry of Health and Social Welfare is taking various health IT initiatives, such as Health Information Exchange, EMR certification, and data-driven hospital project. These initiatives are contributing element in developing Korea's national interoperability roadmap. All of these initiatives have something to do with the SNOMED CT. To promote use of SNOMED CT as a reference terminology, Korean Ministry of Health and Social Welfare provided a research fund to develop maps of the Korean disease classification, medical procedure code, we call it EDI code, used for national health insurance claims, data items from 5 types of cancer registries, and the data items from 33 clinical practice guidelines for Korean traditional medicine to SNOMED CT. And here, I'm not sure if I understood what you're asking correctly, but anyway, use cases for implementing SNOMED CT expressions include SNOMED CT Korean extension. So here we need to implement SNOMED CT expressions to define new concept. EMR certification and health information exchange. Here we need to implement SNOMED CT expression for common data class and items for interoperability. We call it KRCDI. National health insurance claims. Here we need to implement Korean SNOMED expression for Korean disease classification and procedure code for claims, and clinical research for data-driven hospital project and Korean traditional medicine big data project. Here we need to implement SNOMED CT expression for research data elements. So why we chose post-coordination as a solution over creating a pre-coordinated concept or requesting additional concept for inclusion in the international edition. For us, with such a short history, it is really difficult to make a request for inclusion in international edition. So I guess we need to play with a premature Korean extension before we even try to make a request for inclusion concept to international edition. Anyway, based on our mapping experiences, we identified concept not present in the international edition of SNOMED CT. There are concepts we need to clarify context, such as absent, present of clinical findings or time of event or procedure, subject of event or procedure. There are concepts we need to describe disease or procedure in a detailed granularity. There are very complex concepts, such as procedure related to a specific disease, procedure describing procedure using a specific approach or a specific device. And sometimes creating separate concept will lead to explosion of concepts such as acupuncture, with a different acupuncture point in traditional medicine. I have some examples of expressions for defining new concept to be added to Korean extension. This is very little example, there are only a few examples. Actually, we identified over 600 new concepts to be added to Korean extension. So we use the post-coordinated expression to define new concept to be added to Korean extension. Here I have examples. We need to clarify context. So procedure that have not yet occurred, for example, planned chemotherapy, post-operative chemotherapy not administered, procedure not performed at the time prior to the time of current entry in the record. For example, no history of surgery, past history of chemotherapy, disorder referring to someone other than the patient, for example, family history of tuberculosis. Examples we need to represent the detailed level of granularity, especially for research purposes. So data-driven hospital project or Korean traditional big data project, we need to have this level of granularity for concept. So I have here all the concept with the different degrees, grade. All of this detailed concept have a parent concept without any grade information. And bottom example, it's a procedure site with a very detailed anatomical site. Now, example, we need to capture complex concept, such as disorder with other disorders, co-occurring, disorder caused by other disease, procedure for a specific disease, or procedure using specific device, or procedure using specific approaches. So this is the complex concept that we need to use post-coordinated expression to represent this concept. Now we have very interesting examples to introduce to you. These concepts are coming from Korean traditional medicine. So, for example, procedures with the various procedure sites. For example, acupuncture. Acupuncture can have many different acupoints. And then we have complex concepts such as symptom patterns. Symptom pattern which is a symptom cluster. And then we have another group of example, herbal formula, which is a combination of multiple herbs in traditional medicine. If I show you in detail, so here I have acupuncture and the variations of acupuncture, such as electroacupuncture and pharmacoacupuncture. If we list acupoint, there's more than 360 acupoints. So it is really difficult for us to represent this in a separate concept. So we need to use post-coordinated expression somehow. So and there are another examples: acupressure, cupping, which has a lot less body site, but still, a lot of body site for this kind of procedure. And then complex concept, symptom patterns. So In traditional medicine, doctors identify specific pattern of disharmony or imbalance, which is causing patient's symptoms. And doctors determine, based on this symptom pattern, the appropriate treatment. Okay, so after pattern identification, patients are prescribed treatment according to their specific condition. So for these kind of symptom patterns, it is much easier for us to post-coordinate the concept with a list of symptoms, representing this symptom pattern. And I have here herbal formula, which is very similar to symptom patterns. Herbal formula has more than one herb as a component, so it is easy for us to post-coordinate herbs to represent herbal formula. It's very complicated. Now I would like to move on to the practical and technical perspective, how we created, restored, or processed expressions. So we created expressions using mainly language-based authoring, and then stored, displayed, and exchanged using compositional grammar expression. So we don't have expression repositories yet, and we don't have any tools to transform or to classify or query post-coordinate expressions yet. And of course, there is an exemption for procedure, symptom patterns, and herbal formula concept extracted from traditional medicine. For these concepts, I think form-based authoring will be much easier. So storing, displaying, exchange will be easier with the information model that Anna showed to us for these traditional medicine concepts by using separate data element for focus concept and attribute value. So thank you for your attention, but as you heard, we are not at the stage of implementing post-coordination expressions yet. So we only identified which areas that we need to use post-coordinated expressions. Thank you.
Thank you very much, Dr. Park. And this is exactly why it's so timely, right? That we knew that these initiatives are going on, and therefore we need to see what we all can do in the community to help make it right. So it was a very clear presentation, and thank you for sharing your use cases with us. Thank you very much.
Thank you.
So now I want to hand over to the next presenter. And the next presenter is Elze de Groot from NICTIS National Release Center of the Netherlands. So Elze has worked for 14 years at NICTIS, first as an ICT architect and information analyst, but now for 10 years as a terminologist. And these 10 years incorporated the translation to SNOMED CT to Dutch, the creations of dozens of reference sets, mappings, and many terminology bindings for information standards. So Elze, welcome to you.
Thank you, Anna. Hi, everyone. So my name is Elze de Groot, and I'm a terminologist at the NRC of the Netherlands. I was asked to tell you about our use cases of post-coordination. In the Netherlands, we encourage to use post-coordination, but we also know that it's not as simple as it might sound. So we are more and more thinking about use cases where post-coordination really has value instead of very much difficulties for the implementers. So I picked two use cases where we use post-coordination, and one use case is
Elze, are you sharing your slides? I just want to make sure if you're sharing slides
yet,
or if you don't. Good. Good. I just wanted to make sure. Sorry.
So I'm going to this one. So you can see my slide now?
Yes, we see it. Thank you.
Thanks. So I picked two use cases. One use case is a use case where we use post-coordination, but we are discussing the value of it and the way we are doing it. And one use case is use case of post-coordination where we think the post-coordination really adds value to the for the users. So the first use case is terminology binding. In the terminology bindings, we use post-coordination strings in data sets to be able to exchange data. For this, we use a post-coordination tool, and that's used by the information analysts to be able to make post-coordination strings without having to have a lot of knowledge about post-coordination strings. The second one is a complication registry where the post-coordination strings are generated automatically. Complications need to be registered to be able to report them for quality statistical safety purposes. So this is the print screen of our post-coordination tool. You can see that morphology, finding sites, and laterality can be entered by the users. A terminology server is behind the tool, so it's only possible to select existing codes that are in the range of the values. For example, the finding site, it's only possible to select the concept that's a descendant of concept body structure. So in this way, users can easily enter concepts, and the tool makes a post-coordination string, and they can copy paste them where they need it. So information analysts can use the post-coordination strings in their data sets. This is a print screen of our decor where in the Netherlands data sets are managed. Here you can see, for example, that stereo water injection has a post-coordination as a code instead of a pre-coordinated code. So the post-coordination string is used as a code. Systems that receive the codes must be aware of the length of the strings. These are quite a lot longer than the pre-coordinated codes, and the software developers must be able to handle the post-coordination strings. And most software developers in the Netherlands can't handle post-coordination strings yet. So for terminology bindings, we are discussing the value of it. Is it the correct way to use it directly in data sets? Isn't it too complex for software developers? We should be careful that we're making it more complex than needed. It's quite difficult to maintain because in your data set you have to have mechanisms to check for inactive codes in the post-coordination strings. And you also can ask yourself if the data set is modeled in the correct way. If you need a post-coordination, maybe you can model it in another way. So it might lead to less post-coordination needs. And the alternative we are now also discussing is post-coordination that's generated afterwards. So in the data set, you use more structure, and when you need post-coordination, you can generate with templates the post-coordination if you need it for analysis, for example. In the complication registry I'm going to talk about now, we are already generating post-coordination strings automatically. So the complication registry, we are now talking about the complication registry of surgeons. That's actually the one with the most concepts in it. A complication registry is a system where complications are generated based on two axes, complications on the vertical axis and anatomic location on the horizontal axis. And some other attributes are used as well, like the surgical site, intervention site, opening, incision, stoma, at the operation wound. The anatomic location, the coding of the anatomic location is dependent of the kind of complication. So if you have vascular complications, you need vascular structures. If you have nerve complications, you need nerve structures. When we were coding the anatomic locations, not all grouping body structures were available yet in SNOMED, so we had to request them. This is how it looks like. Quite complex, but what you see is complications on the vertical axis. So these are this one, and you have anatomic locations on the horizontal axis. And on the background, they are all SNOMED coded. And for example, I made some examples. One complication is the hematoma of a skin of body structure or the hematoma of an organ structure. In this case, we use a template morphology. The morphology only has some morphology structure and the body structure. And when we code this, we indicate that we have an hematoma as morphology. We have all relevant body structures of skin and organs. And we indicate what the template is. And with that information, a post-coordination string can be generated on the right. So there you also see that the hematoma is the morphology and the skin structure or body organ structure is the finding site. The second example is some more complicated. Besides indicating the template, we use a template for infections where the temporal relationship is optional. And the morphology we need to indicate. We must also indicate that's a post-operative complication because of the surgical site. And we need to use a specific primitive parent. So when we have indicated all these things, the template is used and a post-coordination string like on the right is generated. Where you could find an after relationship, a morphology relationship, a finding site, and the fact that it's an infection, and a primitive parent on the top. This is an example of how we are possible to indicate the different relationships. So these are the morphology, infection, several relationships, a causative agent, a parent, and what template is used. Also, we need a location group, and that's on the other tab. And with all this information, the post-coordination strings are generated. There are approximately 300 complications, so that's the vertical axis, and 250 of these complications were able to make with reusable templates or pre-coordination. And pre-coordination was used for the systemic disorders, so without finding sites. 100 could be done with just morphology and anatomic location. The output is around 2,000 post-coordination strings, all validated with syntax with the use of terminology server. And why post-coordination? Because now we have one platform to maintain the post-coordination strings, and it's easier to replace inactive concepts. And it's an alternative for creation and maintenance of very much pre-coordinated concepts in our extension. And this is the output. So all post-coordination strings that are generated, you can find here. So this was my presentation. If you need more information on this project, you can contact me.
Thank you very much, Elze, and also I appreciate that you spoke about the templates, because we didn't speak about that in the first part of the presentation, and that's a very good way of controlling the expressions that you generate. So that's excellent. Thank you very much. So I will hand over to the next presenter now, which is Jørn Jørgensen from Vestfold and Telemark County in Norway. And Jørn is currently an EHR advisor for the public dental care in one of Norway's 10 counties. And he has been working with SNOMED in dentistry since 2012. And until recently, he was employed by the Norwegian Directorate of e-health in Norway, working with a national project to enhance the use of a comprehensive semantic foundation with SNOMED CT as a central component. And in different use cases, post-coordination has been investigated and even implemented. So we look forward to hear from you, Jørn. Welcome.
Hi, thank you, Elma. Thank you very much for having me here. So I will see if I'm able to share my screen. I think you should see that one right about now.
Yeah, we see it now. Thank you very much.
Now we're back to the wrong, I'm just trying to get you back on my. Okay, let's move ahead. So I'm going to talk a little bit about different use cases for post-coordinations and some considerations we've done trying to implement this in Norway. I'm going to go through 3 different use cases for post-coordination. One is body sites or anatomy for dentistry. One is on dental findings, observations, and procedures. And here comes the dentistry part. So these 2 are fairly old implementations, so they might not conform to all of the guidance now given, but I still like to show them. And then we have the vital signs. More specifically, we have had a lot of work on pulse registration. So I would just like to mention that they are by far design time post-coordinations. What does that mean? That means they're not produced in real runtime inside an EHR. They're design time, meaning they're set up in advance and then used by the EHR as sort of strings that are not actually handled by the EHR. That facilitates implementation, but it also gives us a lot more control on the validity of post-coordinations. I'm not going to go deeper into that. Given 10 minutes, I'm just going to move directly into why post-coordinate. And one is, of course, concept explosion. I'll go into that on the next slide. The second is sort of related. It's describing the single instance or patient. The terminology as a whole, the pre-coordinated concepts, are said to be, are created there, needed to be true and necessarily true. A patient can have a condition, it can have additional features to a condition that are not true to the entire population. Of course, you could say you could always pre-coordinate so that you can reflect any condition on any patient given any kind of context. That would really lead to a concept explosion. For instance, if you have a heart attack, you can have a heart attack due to shoveling snow, or you could have a heart attack due to alcohol or whatever. So it's different. It's important to be able to describe all of these different things without necessarily having to expand the terminology that much. So I'm stating that given the SNOMED's capability of post-coordination, it sort of keeps the terminology open to descriptions of the real world as is. First, body sites in dentistry. This is where we don't actually post-coordinate, but I really wanted to touch on it anyway, because if we were to have all teeth surfaces, all the anatomy we need to describe diseases just in dental arch, we would need to pre-coordinate more than 1,300 concepts, probably closer to 1,500. I've been nice. I tried to restrict my negativity, and that's simply because we have 52 teeth in total, 20 when you're young, 32 when you're growing older. And they're charted by different surfaces. You could count 5 or you can count 8. That's a bit different. Then you have 4 root surfaces, and then you have several roots to each tooth. So that's a minimum of 52 times 25, adding up to over 1,300 concepts. That's not a viable solution. Okay, they're steady. They could always stay there. You won't get new teeth every year, but still, we decided we will not try to do that. We will post-coordinate. Given the problem with post-coordination of surfaces on teeth is there is no model to support it. So we're lacking in attributes in SNOMED. So what we did on this alternative recommendation, and we used the information model. So this is just an example, but what we did is we said body site, which was the tooth, and then surface, which was the attribute. So we have no attribute, no qualifiers to meet this need. So we did it like this. Still, it works. And this is actually implemented. Moving on to dental procedures. So it has some flaws. It doesn't call everything to see if the expression is valid. But remember also, it's done like now, I think it's 5 or 6 years ago. And I'm still putting it up because it's active, it's there. We are currently trying to analyze data given from this kind of implementation. And we're now starting work to enhance it. And we really see that the value of the post-coordinations are immense in this area. And it's a very simple information model. Here you see I picked up this body site, which is the tooth, and the surface, which is also a SNOMED concept. And then we've just put in clinical meaning, because if you have SNOMED and you have post-coordinations, you really don't need to tell whether it's a diagnosis, a clinical finding, a procedure, or an observation. You can just say, here's something. Would you like to look at it? And then SNOMED will tell you whether it's a clinical finding, an observation, or a procedure. So in our data set, we have a combination in the same field in a database with post-coordinations that states that here is something, and we need the terminology service to look at what it actually is. I've just made some cuts from, this is from SQL Server Studio. It's just when we query, you can see that here are they've stated it as ECLs, which is queries, nevertheless. So it's expression, compositional grammar, expression constraint language stating what is the clinical finding? Well, it's a insertion of a white filling with a procedure context of performed. So you could say that this isn't really needed because the soft context is that it is performed, but we wanted this time to explicit the context as we also have planned procedures. Anyhow, the EHR is just for treating these as strings. It's not doing anything with them, but we can do something with them on the back end. I haven't included slides showing that now because of the limited time frame, of course. The desired future where we would really like to go is if we got this relational attribute stating the procedures of the anatomy, we would be able to create expressions inside a very simple technical data model. Now you could always say the expression in itself is also a data model, so it's just a data model inside a data model. But our impression so far is that the expressions gives us a lot more flexibility, a lot more description, and of course, a lot more analytical power if we're able to use them for analysis later on. Moving on, I would like also to show you what's in progress, and this is a bit more, yeah, it's a bit more complex. It's still design time. the previous, you could always say, is it design time when we have told the EHR how to generate the strings and it generates them when you chart? Yeah, probably, because it's the strings themselves are hard-coded, so they're not looked up against the terminology service all the time. This is also design time. It's vital signs observations. Here you can see 17 different types of pulse measurement. Starting with the 4 on top, which are the pre-coordinated ones currently existing in SNOMED, where you have pulse rate. It's measured at the brachial arteria, dorsalis pedis, or posterior tibial. So these are, of course, great, but they really don't tell us everything, because you could either measure them with a hand, you could put your fingers on the artery and you can measure how many beats, or you could put on a pulse oximeter, some sort of device measuring it. You could have a watch, you could have a belt, you can have a lot of things measuring your pulse. And it goes to credibility of data. If I just know someone measured a pulse somewhere, somehow, I might not trust that data. A lot of our devices, if they're hard-coded with the proper string stating an expression, okay, you can know it's a pulse. You can also know a lot more about that measurement. And that would probably increase the trust in data, and it would definitely increase the possibility of analysis. So here comes a lot of expressions. These are the same 17, now written in, I hope, proper SNOMED. And here you can see 2 of them are actually representing what I told you, measuring a pulse on the wrist using your fingers. The other one measuring the pulse with the device on your finger. Say this is, I'm a bit unsure whether I should write in progress or under implementation, but we're very close. I think I have the time on it to skip one slide and then go back, because just to show you how it's done. This is a fire example where we have just sliced up fire and said, well, here's an observation. It has an ID. Here comes the coding system with LOINC, because that's mandatory in fire, but it doesn't give us all information. So here comes the proper expression that gives you all the information you need, stating this is measured by a pulse oximeter. And this is currently starting to work. We, of course, have one problem saying, how do we consider that all of these are pulses? Because here's a different top-level concept. So we have some question statements. Some of them are the same as I did in Portugal, but still, we think post-coordination is necessary to represent knowledge known to be true only for that particular instance or patient. We don't know if it applies to everyone. We need to describe it now, and post-coordination is probably the proper way to do it. We think that will increase trust in data, adding the information you have, not expanding the data model of a classical XML or a JSON, but keeping it inside the compositional grammar and the SNOMED concept model. Then you have something from a technical or ontological perspective. I know you were into this, Anna, and I would really like to dive much deeper into it, because is there a need to give them unique identifiers, or are they simply strings? How do you do that in the SNOMED server? I would like to hear more about it later on. We discussed whether there is need for classification. I still don't see with normal form how this would apply. I just can't vision it. I think you have the answer. But we're still struggling. I'm struggling inside my head. Should we go all the way to OWL2 to represent it and then be able to query them? And of course, you mentioned analysis based on ISA's assumptions. I would also really like to be able to query on attribute value pairs, and the system should enable both. And I think we're getting there. And given a bit down the road, I hope to be able to show you also how analysis is done on these data, which are actually gathered quite stupid. They're just strings, but given stupid data with the proper structure, you can use terminology services to do really good analysis on the back end.
Which is exactly where we want to go, right? being able to get full value out of the data that is recorded. Thank you very much, Jørn.
And if I may add a comment, someone said it's hard to get the EHRs to implement post-coordination. Well, let them think they don't. Just
exactly
know how to do it, and we'll handle the data on the back end. It's a closer path.
And I think that goes with any type of implementation of SNOMED. The clinician should see the clinical words, and what goes on behind the scenes could be expressions, could be concepts. I agree. That's where the logic should lie, the computer logic. And with respect to some of your questions, I'm also very keen on going into a discussion and hopefully answer some of these. And I know with respect to the identifier part, there are different ways that it can be done. And maybe Michael in his next presentation will touch on this. I'm not sure, but he could. Otherwise, we can follow up on it later. And there's also documented in the guide how you could approach that. So let's follow up on that. And here comes Michael. Hi, Michael. Thank you for being here and welcome. And you are, I'll just give an introduction of you. So Michael has a deep expertise in clinical terminology and specifically large ontologies such as SNOMED, and of technology developed by Michael and his team has been licensed nationally and nationally by standard bodies, government organizations, and SMEs. So Michael works for CSIRO, so many of you may be familiar with OntoServer, and I believe that Michael is now going to give you some insights on the OntoServer approach to expressions. One thing to mention is also that Michael in 2018 received the award for excellence from SNOMED International for the many contributions you've made to SNOMED CT over the years, including the discussions on post-coordinations that we have had in the languages group. Welcome, Michael.
Thank you, Hyeoun-Ae. Hello to everybody. We seem to have quite a crowd. I'm going to talk a little bit about OntoServer's support for post-coordinated expressions. I don't need to, I hope, introduce OntoServer except to say it is a FHIR native terminology server. So the approach to supporting SNOMED in OntoServer is through the FHIR APIs, and that is also the approach that we took to supporting post-coordination. We introduced this in version 6.1 in October 2020. So it's been in there for quite some time. I think we're now up to 6.13. So it's a few versions since then. And the level of post-coordination support that we support is level 0. So if you're familiar with the new guide to post-coordination, which talks about the different transformation levels, level 0 is the level where there are no transformations, and the expression is expected to be machine-readable concept model conformant. In the 3 years since we introduced this support, the only significant change we've made is actually to enforce machine readable concept model conformance for those expressions. So we always expected them to be conformant, but now we actually check and require them to be conformant. In terms of the sorts of things that you might want to do with post-coordinated expressions in the terminology server, we sort of categorize them into these sort of different areas. So understanding them, checking them, querying records with them or using them in queries of EHRs, searching for them. So, you know, if you've got a library of post-coordinated expressions, you might want to search for them, and effectively extending SNOMED. So this goes to a little bit to that design time use of post-coordinated expressions. So in the FHIR API, there are conveniently a number of different operations that address these different things. So there's a lookup operation, which allows you to understand a post-coordinated expression. validation operations that let you check them, subsumption and closure operations that let you do the querying, expansion operation, which is how you search for a code or an expression, and then the notion of a code system supplement, which allows you to extend an existing code system with additional content. Normally that would just be things like synonyms or additional properties, but we also allow for post-coordinated expressions. So it allows you to mix those into an existing release. And those interact with features like the expression constraint language and the filters in a value set definition. I won't go into the real nitty gritty of all these operations. I'll just give you a quick sort of flavor of them. So this is what you might do when you're looking up a post-coordinated expression. You pass the expression in, and you'll see with the curly brackets there, this is a MICM conformant expression already. And you'll get back some information about it. So in this case, it invents in a structured way a display text for it. It tells you the version that it used to get that information. It will check it as part of that. So if it's not conformant, it's going to return some error. It will normalize the order when it returns that information. So you get consistency. And one thing that would be nice to get back is a breakdown of all the property values from the necessary normal form. That's something we did not include in the first implementation. We still haven't included it. We haven't had strong demand, or in fact, any demand for that feature. But it is on our roadmap, just without demand, it's hard to prioritize. Validation, similarly, you pass in the expression and you get back a validation result. Originally, we didn't do MICM validation, now we do. Subsumption, we're subsumed, so you can ask for these concepts. Is this concept and this expression, do they have a subsumption relationship? You can, it understands that the order of the refinements doesn't matter. And then with expression libraries, these are supported through the code system supplement. They allow you to define display text, and they enable value sets to return post-coordinated expressions. So this is an example of a code system supplement. You see it's got some metadata for managing it, and then it's got the expressions in there. So it really just says, here's a set of expressions that I want to work with. You can include custom display text in there. Otherwise, you just get the automatically generated text. It's worth discussing briefly some of the gaps in the Fire API or some of the underspecified elements. And this is not something that's specific to SNOMED. It applies generally to the standard, and also reflects some things that haven't been sort of, I guess, fully worked through, because working with post-coordinated expressions or post-coordination in general is an emerging capability. So there's not a great deal of on-the-ground experience with it. One of the things is how to deal with equivalent code. So if you have a value set that contains expressions that are equivalent, or a pre-coordinated concept that's equivalent, and you expand that, should the expansion include all these codes, which effectively means you've got duplicate entries, or should it normalize it down to just one of those entries, or some other way of collapsing them together? you need to be really careful. Once you've got post-coordination, lexical code equality is not the same as code equivalence. So we see this all the time. Systems compare codes. They say, is this code equal to that code? That works when they're case-sensitive codes and they're not expressions, but it doesn't work when you've got expressions. And then in the closure operation, we've got a similar question about these equivalent concepts. Should they be included in the results or not? There's some other things, and this is probably out of date. The triple less than prefix on a post-coordinated expression means actually this is a primitive concept, but primitive things can't ever be equivalent to anything else in this post-coordination context. So they're actually not particularly useful in the API, so they're effectively deprecated. I guess the other thing, the last thing to talk about is where the limits are in the current OntoSurfer implementation. When you're using expression libraries with code system supplements, you have to explicitly reference those supplements by version to be able to have them included or have them in scope for the various operations. In value set definitions, querying and ECL, querying the hierarchy of post-coordinated expressions works, but querying on the attributes is not yet implemented, so those things won't work. And as I said before, we don't have any explicit support for closed user forms, and so that's a feature for the future. Depending on also on demand, we've been quite conservative there because we're concerned about giving indeterminate answers or unexpected answers, and so we want to have real clinical fidelity. So that's why so far we've stuck with level 0.
Mm-hmm. And thank you for mentioning the levels, Michael, because that's a great segue to Kai. And just to follow up on Jørn's question about the identifier, we saw here in your example how the code was treated as the full expression was treated as the code. So thank you for showing that. And now it's time to hand over to Kai, my colleague Kai Kewley, also from the implementation support team at SNOMED International, who is going to talk more about these implementation levels and the Snowstorm approach to support for post-coordination. Over to you, Kai.
Great, thanks, Anna. I'll share my screen.
And we have some questions in the chat, and we will just do a follow-up on these after Kai's presentation. Thank you. And thank you for raising these questions.
Can you see my screen okay?
Yeah, we see it. Thank you.
Great. Hello, my name is Kai Kewley. I'm a software engineer, amongst other things, in the implementation support team at SNOMED. So SNOMED International is supporting implementations by providing up-to-date guidance on post-coordination, as we've talked about, and also some open source tooling with the required capabilities. So this reference implementation is Snowstorm X, and this is the beta version of the Snowstorm terminology server. Before I move on to Snowstorm, I'm going to talk a bit more about the levels of transformation, which Michael Lawley mentioned. So post-coordination can be hard to get right. To produce a complete expression along with the attributes that are required and the attribute groups ready for classification, you need some understanding of concept authoring. and to have checked the current state of the existing concepts that you're classifying against. Now, during the creation of the guide, the SNOMED Computable Languages group explored some options for automation to make post-coordination simpler for implementers. This diagram represents 4 levels of automation using expression transformations. Now, right at the bottom, we have no transformations. This is level 0. Here, a healthcare system implementer must create a user interface that produces perfect classifiable expressions. And this is achievable using carefully designed expression templates, which I think Elze touched on. The very top of the diagram is level 3. This is where there are very little constraints. The terminology server has to do its best to transform the input expression into something that's classifiable. This is the highest level of flexibility and automation, but it also has high risk. And because the transformations won't throw an error, even if the expression is, the meaning is ambiguous. So it's probably only appropriate for some research data mining use cases. For now, in the guide, we've designed processes for level 0 and for level 1. Level 1 allows a small set of 8 conservative transformations with simple inputs to reduce complexity for implementers. These are the full list of the level 1 transformations. The first transformation allows refining a concept by making one of the existing attributes on the concept more specific. For example, giving a more specific finding site to a disorder. The rest of the transformations are for qualifying the meaning by adding new attributes. Some of them may change the domain of the concept. For example, if you add context to a clinical finding, like the example shown is adding a suspected context to a disorder. This will be transformed to the finding with explicit context domain. These transformations behave in different ways, but they all require just one focus concept and at least one attribute as input in order to produce a complete classifiable expression. In Snowstorm X, we have implemented both level 0 and transformation level 1. Snowstorm X, as I said, is the beta version of the Snowstorm terminology server. And this project gives us a way to publish new features for trial use before those features become mature and are moved to the main Snowstorm product. Post-coordination support is given via the Fire API, similar to Onto server, and it uses co-system supplements as the expression repository. Implementers can choose to use level 0 or level 1. Level 0 includes validation, incremental classification, and this implementation allows selecting published concepts and post-coordinated expressions using ECL and using both, focus concepts and attributes. Level 1 includes all the features of level 0 plus the set of 8 known transformations, which are detailed, quite thoroughly with examples in the guide. The Fire responses do contain some non-Fire conformant information, like the inferred attributes, the NNF, and also equivalent concepts. So compared to Onto server, there's more features, but this has only just been published as a beta, so it's definitely less mature than the Onto server implementation, which has been around a few years. I'm now going to show a user interface to demonstrate some of the best practice principles for post-coordination. This demonstration interface was created by our implementation support colleague, Dr. Alejandro Lopez Osoño. And I'll see if it's going to behave today. Yeah, so the blue box here shows a demonstration clinical user interface, just the blue area. And there's lots of white boxes that show what's going on in the background using the Snowstorm X terminology server. The first example is diagnoses. And as a user, I want to capture a patient diagnosis of kidney stone in the right kidney. So it's lateralization. So I'm going to look up the focus concept kidney stone. And then the user interface allows lateralizing any disorder if it has a lateralizable body structure. So I can select right and I can save. And this is the necessary normal form that's come from the classifier. And we can also use ECL, the expression constraint language, to search the concept repository and the expression repository. And we get a mixture of pre-coordinated and post-coordinated expressions in the results. So this example uses one of the transformations, but transformations aren't always needed. So the second example I want to show is for capturing wrist fractures. Now this form has been designed to reflect an expression template. So the options are constrained to create a good classifiable expression with the correct role groups already from the user interface. I'm going to pick all the first values because there's something I want to show here. So I want to say that we've got a wrist fracture and the bone that's fractured is the distal radius, and the morphology is an open fracture with a posterior displacement. Now, when I save this expression, we get the classified necessary normal form, which is for querying, but also down here we get an equivalent concept. Now, a user interface should, depending on the design, it could give the user the option of instead of saving the expression generated by this form, because there's an equivalent concept that has the same meaning, the user interface could give the user the option of saving this existing published concept on the patient record instead of the expression. I guess that would simplify the job for receiving systems. Okay. So I don't have much time. I'm going to show one more. This is another tab that demonstrates, it's more focused on the transformations, the 8 transformations of level 1. So there's many dynamic options that use the various level 1 transformations. This user interface gives a lot of flexibility, but presenting a clinical user with this many options at once is probably not ideal. So I'm going to focus on refinement transformation again, and let's refine a clinical finding. I'm going to use the example of skin cancer, a malignant neoplasm of skin. And as I said, it's a dynamic interface, and it allows me to qualify, refine, further qualify the expression. And I want to refine one of the existing attributes on this concept, the finding site. So instead of just the skin structure, I want to be more specific. So this interface allows us to search for subtypes of skin structure in the hierarchy, and I'm looking for nose. So this now represents the skin cancer on the nose. So again, we can transform it. The transformation has occurred, and the classifiable form shows that the new finding site with skin structure of nose is here, but these curly braces show that for the classifiable form, it needs to be in a role group with an associated morphology. And that's how we get the correct necessary normal form from the classifier. And the classification process has shown that we've actually picked up 3 inferred parents for this expression, and that will help it to always give the correct result when we're using a querying using ECL. So I hope that gives you just a taste of what is possible with SNOMED CT post-coordination. I'm going to switch back.
And yeah, so there's a question about the demonstrator being available.
It is available. So I invite you to try the demo interface yourselves over the next few days and weeks. we might find that straight after this, it goes down because everyone jumps on there at once. So come back in a few days and, give it a try. The post coordination guide and the Snowstorm X features have a trial use maturity level. So we're really looking for community feedback in this area over the next year or so.
Yeah, and that would also be for the presenters of today's sessions. So we've seen examples of some of the expressions that you have created. So maybe that's a time now to actually go and explore whether the creation or the expressions that you have created fall within these different transformations supported, and whether they are can be classified. So I think that would just be a recommendation for you to explore your use cases in that way. So thank you, Kai. Should I take over the screen and then we will wrap up?
I'm just reading questions now.
Yeah.
The first one's easy. Will you send us the presentations of the webinar?
So we will definitely make the recordings available. I'm not sure how and in the USRG space, we can put up the slides. So if I could ask the presenters to forward me the slides, then we will put it up on the USRG side. All right. So I know we have run a bit over time and we apologize for that, but I just want to ask if any of you have any questions before we wrap up this this session. Just run over these slides. So if you have any questions, then after you have watched this or listened to digested some of the things that we have covered today, please send us an email if you have questions on implementation@snomed.org. The email will come in a subsequent slide. We are really eager to go into any discussions about this, so please reach out. If you want to join the SNOMED implementation community and be notified about upcoming implementation webinars and other implementation news, you can visit this site, snomed.org/USRG. Scroll down to find the registration form, and then you can join the user support reference group, and you'll be notified with emails when implementation webinars happen. We also have other webinars within our SNOMED International's web series program. We have clinical webinars, research webinars, and then these implementation webinars. And the next webinar that will be held is on May 31st. It's a research webinar, and it's entitled Technological Model of Interoperability of Electronic Clinical Health Record Systems with HL7 FHIR and SNOMED. And it's not that I have learned Spanish, it's that I have translated the title beforehand. And just to note that the presentation will be given in Spanish. Also, I just want to advertise for our upcoming expo in Atlanta in October. So it's on the 26th and 27th of October, and we really hope to see you all there. Maybe we'll hear more on post-coordination there, I'm sure. But there will also be other great presentations and exhibitions and so forth. So we definitely hope to see you there. So I'm just looking at the questions that came in. Is any SNOMED? Yeah, there we have the user support reference group. It's about the question if there's any SNOMED CT forum to discuss these topics. And I would say if you go into the USRG page, snomed.org/USRG, as I was showing just before here, we can set up discussions on post-coordination if there is a momentum for that, and then we can facilitate discussions about these topics. And I believe that leaves me to the last slide. I'm really sorry for running a bit over time. I want to thank you all for attending today, and I hope that you enjoyed the session. Also, thank you to all of our great presenters. Thank you very much. Bye-bye.